Element 7. Element 6 would be carbon. If there were 6 protons, it would be carbon. So, I always bring a periodic table to class in chemistry or something. So, 7 positive protons makes it nitrogen. If there were 10 protons in the nucleus, it would be neon. 26 protons, 92 protons, you get the idea. The neutrons can vary, neutral neutrons can vary quite a bit from element to element, isotope to isotope. Not all nitrogens are created equal. Not all carbons are created equal. Not all hydrogens are, not all elements of each, not all atoms of any one particular element are identical. They change up. They're called isotopes, yeah. And if I had 10 negative electrons, that 10 negative electrons, that's 10 negatives and 7 positives, 10 negative plus 7 positive, doesn't that come out to 3 negative? So isn't it, let's see, nitrogen and 3 negative, and, well, this bottom number is the number of protons, so 3, and the top number is the sum total of the protons plus the neutrons. Did you give me H, is that right? Is that what you said? I think it is H, yeah. Whew. Yeah. Yeah. If it's an ion, as they're listed on the table, we're implying these are pure elements, just atoms with the same number of positive protons and negative electrons. So carbon has 6 protons and 6 electrons. Oxygen has 8 protons and 8 electrons. Neon has 10 protons and 10 electrons. But many of the elements, as we'll soon find out more about, they like to gain or lose electrons. If you gain negatives, too many negatives compared to the positives makes it an ion, a negative ion. It's called an anion. Or if you're a metal, many metals like to lose electrons. So all these elements, from here all the way over here, they're all metals. So all these love to lose electrons, and they have more protons, more positive protons in the nucleus, and that makes them they're called cations, or positively charged. So on this picture, I had 7 positive protons and 10 negatives. So it's just a silly positive negative number thing. 10 negatives and 7 positives makes 3 negative overall. It's so simple, it's confusing. Good question. Okay, cool. So, what am I doing? Here we go. Yeah, so isotopes. In the beginning, like 100 and some years ago, we thought that all atoms of hydrogen were the same. And they do all have 1 proton and 1 electron. But some hydrogens are a little bit heavier. They have 1 neutron. I forget the percent breakdown, but less than 1% of all hydrogen atoms in, say, water, H2O, are deuterium, and very, 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 very few of them are tritium. They have 2 neutrons and 1 proton and 1 electron. Yeah. I'll say more about the scale in a second. Okay. So what does that mean? That means that this one weighs almost twice as much as this one, and this one weighs almost 3 times more than this one. The protons and the neutrons are super duper heavy and super dense compared to the electrons. The electrons are like flies, and the protons and neutrons are like a cow. They're like heavy, dense. You can't move them. Have you ever do it? So this one weighs almost twice as much as this one, and this one weighs almost 3 times as much as that one. So I think I have a question here. Yeah. Oh, well, oh shoot, that's obvious. Is it obvious? So there's the percents. Do all water molecules weigh exactly the same mass? Maybe it's not obvious. Are all oxygen atoms exactly the same? They're not quite exactly the same. I haven't told you what their isotopic composition is. Many oxygens just have 8 protons and 8 neutrons. But some oxygens have 8 protons and 9 neutrons. Bump it up one. Not all hydrogens are created equal. I'm not even open on the top half. Sorry, I would maybe I presume too much. But no, some waters are heavy and some waters are light. All right. So if that's true, let me throw this out. Let's assume oxygen. Bad assumption, but assume oxygen's always 16 mass units, atomic mass units. If hydrogen could be 1 atomic mass unit, or 2 atomic mass units, or 3 atomic mass. What are the possible combinations of varying the hydrogens on this 16 for the water? How many different integer mass possibilities are there for the mass of water? This is not obvious right away. Oh, it's multiple choice. So I'm going to shut up for a minute, and the learning assistants are going to give you a clue if they dare, if they can. I don't know.